actually what I want to talk about is the way that we might look at our most important things that we have within the IT organization and how taking care of them has kind of evolved during the last few years in how we're handling IT infrastructure, and that's applications. Like, if you don't know about F5, F5 has existed for quite a long time, and we've been very, very innovative in the way that we're doing application delivery. Innovating with application delivery controllers and so forth being a big part of creating opportunities for customers to deliver applications securely and fast. And we've identified a lot of issues today about modernizing application development and what we're seeing over time. I mean, applications today, there are opportunities for companies to deliver growth from them, increase revenue. This is where a lot in the digital market space that exists right now, where companies want to invest money in. That's where they can get some revenue back. They will get in the investment back some way. But there are challenges, and we see that a lot with the type of modernization that is happening. We can see that from patterns in types of how development is done of applications. I mean, we've had monolithic applications, and we've been used to them, and we've been doing some things to service them and split them up into smaller pieces so that we can have some form of autonomy when it comes to developing these and handling the life cycle of these and exposing them and having security done for them. And we see this type of pattern increase time and time again the more time goes. I mean, now we have another type of pattern with microservices and other types of strongly decoupled or loosely coupled autonomous systems or services, however you want to call them. Essentially, the way that we're doing applications are increasing in difference, especially when it comes to serving these as best fit the actual service or the actual system itself. Previously, when we talked about where we could deliver these applications, they were pretty much determined on where we had the infrastructure necessary to deliver it. But in this new world, where we're splitting these things up and we're creating autonomous pieces, we've started to come to the realization that, hey, some of these pieces might be serviced best from different types of infrastructure, different places, different types of sites. I mean, we have the data center, we have public cloud as a big accelerator for innovation, but also some new consumption places, such as edge, consumption closest to the consumer, compute and everything that has to do with delivery. I mean, what you have to realize is that all of these different methodologies and different infrastructures that you want to employ to deliver applications from a distributed systems perspective, it's going to increase complexity. It's going to increase the problems that you will face, both in terms of connectivity, but also security and visibility. And this is an issue. I mean, if we're looking at the journey that you might have taken with the traditional data center, you've taken an application, you destructured it from a monolithic into more handleable pieces, and maybe you've moved then later into a hybrid IT environment. You've done a lift and shift into some public cloud because you wanted to accelerate innovation. Then you might have looked into multi-cloud, and you've started to implement another public cloud into the mix, and you've seen that, yeah, in order to support my increasingly microserviced applications, I have implemented more features and more infrastructure and a bigger tech stack to solve stuff in AWS. I haven't really done that in Azure, so I cannot really support that type of infrastructure. And my data center is lagging behind as well because I couldn't accelerate as fast as I could in the public cloud. Suddenly, we start to make decisions on how we can run these services. How can we distribute these systems based on the available tech stack that we have? The limitation becomes technology. It doesn't become about what actually is the best fit for the application. The vision that F5 has and what we've identified when it comes to these patterns of distributing systems, of creating services that are autonomous, is that we shouldn't govern how we do deployment of them and how we manage them based on limitation in technology. They should be distributed. Like if there is, for instance, we have an application and we've serviced it, microservices, split it up into autonomous pieces, and we want to have one payment service done by an external party, I mean, that should be done, and our decision-making on how that service should be done should be based on what does that application service need, that individual piece, that autonomous piece. We want to make sure that application developers, and whoever they are, they have the ability to individually set their own goals with their autonomous piece to make them autonomous. Otherwise, we're not creating that. And the vision that we see in front of us, and what we see is a real challenge, is creating this ability of saying that, yeah, some piece of this application that fits best to run inside of maybe in this case. Google, they have the best machine learning technology, and some stuff we want to have in Enterprise Edge. And some other piece of the application, we want to run that in the data center, and some stuff we want to run in AWS and Azure and so forth. But we can make decisions based on what fits the service and or that particular piece of that distributed system best, and not make decisions based on the tech stack and the limitation that exists there. And this, is a completely different thinking when it comes to delivering applications. And it's crucial to remember that, delivering applications. And we'll come back to that, because that is something I want to talk about also when it comes to this type of solution. But moving from a very siloed operations approach, where you have selective technology stacks that you either started at different times when you've done this journey, or maybe because you have limitations in the type of IT organization that you have, the people that you can employ. But transitioning from this siloed approach, rather a siloed operations approach, to an integrated operations approach, where you can see all of these available sites, whether they are an edge location, a retail site, or a charging pole for an electric car. It would be the same type of deployment type for an application as would your public cloud environment in a VPC in AWS or your data center. I mean, this is a type of dynamic environment that we see is necessary for the foreseeable future when it comes to this type of application development. And usually, when you start talking about distributing systems, the first things that comes to mind of, okay, what do we need to start to solve in order to get on with this journey? What do we need to do? And usually the first thing we talk about is, we have to solve the networking. We have to solve communication. So let's start about that. How are our organizations addressing this today? Like if you're looking at what analysts are saying, that they're trying to do all of this communication between these different types of sites using a lot of cloud-native tools, virtual routers, automation tooling to make sure that stuff is being deployed across all different sites at the same time, so we have some similarities between them. Other people are using some interconnection architectures. Others are looking at some SDN platform to solve this. Others do nothing. See this as, this is a very complex subject. I'm not going to even to attempt to deploy it. And many say that, I'm going to go solo cloud. I'm not going to do this multi-cloud. But we know for a fact, we cannot really ignore a problem. This is something that has necessarily been brought up by a lot of other things, like risk reduction, ability to execute, innovation. We don't want to make decisions based on this is a technical limitation. If we want to make something and we want to be competitive or deliver the best to consumers, we should not be limiting ourselves in what's technically possible. So what the challenges are, what we see, first of all, is that the interest of this type of technology has increased 5-fold over the 12 months that has been. During pandemic, this has been something that is really, really interesting. And why is that? It's interesting to think about. I don't know. I don't know really the answer. I can think a lot personally of why that would be during the pandemic, why people would invest more and more into different types of sites and architecture. But I would argue that most of it has to do with the way applications are developed and the way that we think that they could be deployed today. But also that the networking features that are implemented today that can be used natively in clouds and other sites, they are not good enough. They do not provide the necessary stuff needed for applications, automation to be done, automation deployment, and we see a lot with the DevOps team that what requirements they have, there is no one key to fit all. So what happens here is that there is a lot of segmentation when it comes to this type of networking, the solutions that are existing in the world today. And you have to look into what is the actual problem? What we looked into and what we found out when we started to see just looking at networking, what is the real operational challenge with doing it? So having different types of environments, you see that there is so many different capabilities between these native solutions within these when it comes to communication that even trying to implement something becomes extremely complex. If you want to automate, you suddenly have a lot of management overhead. and you want to do a lot of configuration that is very specific for each type of environment, and you're starting to build fragmentation yourself in the type of deployment that you do, and you start to need more and more people involved that have specialty knowledge already. And the solution that we see is, abstracting away a lot of the complexity. Something needs to be done about this discrepancy in terms of capabilities, because we cannot have fragmentation start at the communication layer. That's not really going to set the foundation ready for something that can be more, integrated operated rather than siloed operated. And the next thing becomes about policy making. Like, how do you centralize policy making in a fragmented world? How do you spread out those policies from a centralized place? And how do you manage the metrics then and the observability that you would want to have in such an environment? And I think the last thing, and we talked, or I said it quite early about the applications. Most solutions end here. That they say that we've solved communication between applications, now we have multi-cloud networking done. But I would argue that there is a different approach if the end goal is connecting networks versus connecting applications. Most of the things that we talked about and the reasons of spreading out services, that is because it's communication between those services that are needed. Whether that is from a consumer that wants to have ingress communication into some service, or it's between these distributed systems. Looking at some examples, you have data center to cloud, moving apps out of the server firm into the cloud. Maybe you want to utilize some of the more capabilities that exist there, but some EU regulations make sure that you cannot just move data to the cloud. You have to stay inside of some data center somewhere. Well, what about this communication? It's not just a network connected to another network. We want to create a connection between some service to another service. It's an application to application communicating with each other. The same goes for cloud to cloud. Maybe you're using some cloud native functionality in some cloud that you want to still use, an IAM system or database or something, and you want to have access to another service that lives somewhere else in another region, another cloud, for whatever reason. It's still application to application connectivity. And the same goes when we're talking about edge location as well. Let's say that we have a charging pole for electric cars. And we want to make payments there, so we want to have the entire payment system run locally because we want that to be fast, because that's the competitive advantage we would have against other charging poles. And then that system would have to connect to some other system up in a backend somewhere. But that's also application talking to another application. And there is a difference here, and it's important to see that distributing applications, distributing systems, this is not just about connectivity. It's about a lot of other stuff in between that makes sure that you can do efficient application communication. And realizing that there is a difference between connecting networks that requires a network-centric approach with network security versus connecting applications. Connecting applications requires an application-centric approach augmented with application security. And this is really key. And this is where we see that a lot of competitors maybe are not taking the next step into. And where the legacy of F5 as an application delivery company maybe see that there are more challenges than just solving the connectivity side. There are other services. Let's say that we're taking a site and we want to implement an entire stack that is needed in order to do applications delivery. I'm not saying that these are all services, but it's a few of them. Routing, to make sure that connectivity exists, that's just one thing. You also have to make sure that you have a good content delivery network globally in order to deliver that application. You need to have web application and API protection in place. You need to do load balancing. You have to do API management. But not only that, you also have the need of running the actual workload. How do you do for modern application, the container management platform, the secret management and distributing that in this distributed system? Getting the logging and monitoring out of the system as well. That needs to be implemented. You need to create some CM system that goes in and aggregate all of this data so you can, for one request, correlate between that security event and whatever networking event happened. There's a lot of work here. But maybe let's say we do this. Let's say we have a lot of stuff. We have engineers. We implement all of this stuff. We automate it. It's a lot of management plane, but we do all of that. Good. And then we introduce another site. So now we're talking about the charging poles. The charging poles needs the same thing. Oh, you can't implement the same thing. You need to do another approach for the routing, another approach for the application protection, another approach for the load balancing, and suddenly you're segmenting yourself and fragmenting solutions. The same goes when we add another one. And I mean, this compounds. So the more type of sites we introduce, and this could be like just purchasing another company that has another type of data center with another tech stack, it introduces the same thing, fragmentation. Fragmentation in the data systems or distributed systems world is bad. You don't want to have fragmentation because that makes that you are siloing yourself in what you can do. And this type of complexity that's introduced as well, that's something that can't be ignored. The same goes for the software integration here. Automating across this to make sure they have the same type of automation between all of these sites is going to be extremely hard. Well, and I said, like, what happens when we move towards the edge, towards deployment methods that are completely different from doing stuff in a centralized environment like a public cloud? Like, what's when we want to implement applications into moving trucks? I mean, that's an edge location. Or trains that needs to have their own system internally in order to make sure that they have all of the applications needed for long-term high-speed trains. I mean, just examples, but these are new deployment methods that need to be taken into account. And the same goes for this policy thing that we talked about. Like, how do you centralize policy decision-making and distribution of that in a system like this? And getting the good observability. That will be an operational nightmare. Just implementing a CM system that can aggregate across an entire system like this is going to take a lot of time. And yeah, now I've presented all of the problems, so I'm not going to leave now, and we're not going to talk about anything else. No, of course, there is maybe something that we can do, an approach that solves a lot of these issues. What about if we could consolidate this into one service that is agnostic no matter what type of environment we're talking about? So it doesn't really matter if it is a data center, if it is a charging pole, or if it is a public cloud. I mean, what if we could have something that has the exact same feature set, that works the same way, that has a consolidated way of running workloads, where everything is SaaS-based, so the control plane is one, you automate against one endpoint only, so you don't have this management overhead, and is common tooling, meaning that there is no difference between the configuration you would have to push to one environment over the other, so you have standardization. And one place where you do all of the policy making and distribution of those policies, and where you aggregate all of the data and get observability into a distributed environment like this. And luckily, that exists with F5 Distributed Cloud Services. This is the next step in F5's new approach of delivering their application services. We've traditionally had this ADC platform, a big infrastructure piece that you put in your data center, and we delivered services from that. And now it's SaaSified. And we have built our own distributed cloud service platform that is, instead of creating an environment that is segmented like this into different silos, where you're creating a separate enterprise edge tech stack, you're creating a separate private data stack, you're creating an edge provider edge stack, or you're creating a public cloud stack, or even for all the multiple public clouds there exist, and trying to automate across these and employing a bunch of specialists in each of these areas in order to implement their specific tech stack, where you might have some places drift after the other, so that I can't really deploy this service in my Azure environment because I haven't deployed my new fancy thing there. So no, sorry, Mr. Developer, you cannot do that. You will have to do with this environment. We want to escape from that. So the distributed cloud platform is an abstraction layer across all different types of sites where applications connect into. And we deliver application services from it in a singular way, no matter what type of environment there is. Communication is done for you. You don't have to do any of routing. We're creating an overlay networking model that solves that for you. And implementing a lot of front door security service along with actually running the workloads and distributing them. So you can have one singular place where you can manage and distribute systems, no matter if you want to run one singular service inside of that charging pole and the rest of them in public cloud or vice versa. So this is one common horizontal stack, no matter what type of environment you have. So you can create that standardization. You can have one place where you do all of the automation, and you have one place where you can get the aggregated data of this distributed style of doing application delivery. So yeah, doing multi-cloud delivery, I would say that's one thing. Extending modern app, making them able to scale in an environment that looks like this. And also securing the applications with, proven F5 technology. I think that's 20 minutes, right?
Sharp.
Good.
So thank you, Anton.